Everyone, and welcome to Tech Topical, Tech's best talking show. Today, we have another exciting topic for you, as we always do. Today, we're going to be going on a journey through the history of computers and the history of all things computer science. We'll be learning about a bunch of it's going to be a crazy talk. We're going to be listening to Uncle Bob, and he's a known figure in the industry, I assume, because they've given him his own moniker. So this is going to be very exciting. And of course, I have a very exciting guest for us today. He is a Tech Topical favorite and known for writing a book in the Bible. It is back-end web concentration student at Make School. It is Jeremiah Leary. Welcome, Jeremiah.
Thanks for having me, Brian.
Was that right? Is it Jeremiah? Yeah, it's Jeremiah. Oh, the Bible fell. Put that. Okay, we'll put him down. All right. Anyway, welcome, Jeremiah Leary, back in web concentration student at Make School. And Jeremiah, I think, is a uniquely qualified person to watch this video with me because he is one of the people who I think has the most curiosity and interest in the inner workings of computer science concepts, coming from nothing to a lot of something. Wouldn't you say that's the case, Jeremiah?
I'd say that's pretty accurate. I'm usually not satisfied with the surface level teachings, and I really got to kind of dig down and get through the rabbit holes to figure out exactly how stuff works. So this should be interesting. Galactic
Bacon in the chat putting us with that. Who is Uncle Bob? Well, I'm glad you asked. It's the guy who's on the screen right now. Let's go ahead and see what he's got for us today. Let's see. I think you're gonna like this, Jeremiah. This guy's he's a character, and it might be, I don't know. You're gonna find this talk interesting if you find a lot of times in life we have, maybe the I hate to point it out, but you have the old guy that wants to tell you about the back in my day type of stories. And sometimes we aren't really too inclined to listen to the back in my day stories. But if you do listen to the wisdom that age has accumulated, then we might actually be able to learn a little bit ourselves. So, let's give this guy a shot. Let's see. Maybe this will be really interesting. Not really sure. Haven't watched it, but I hear very good things about this talk. And I don't know. I watched the beginning. I watched the end. Both of those parts were good. I'm sure the middle's fine. Let's go ahead and take a look. Let's see what happens. All right. Ready? The Last Programming Language by Uncle Bob Martin. And when you see a guy with a hat like this, you kind of, I don't know. I kind of get a little bit more interested.
Automatic credibility.
Automatic. We're gonna Indiana Jones our way through this. All right, here we go. Hello. That's okay, Uncle Bob.
Hello,
yeah,
my name is Uncle Bob. Brian, please turn on the audio.
What happened?
We're not getting any audio on.
You're not getting the audio? No. Okay, here we go. Ready? Stop screen sharing. And I'll do the theme song in the meantime. Tech Topical, Tech's best talking show. Tech Topical. Tell me what's the topic, yo. Tech Topical. That's how the theme song goes. Okay, here we go. And let me know if you can hear it now. Good.
It's still a no-go on my end, at least.
Literally was just working. Okay.
It was.
Right, you may have to share just the tab.
Okay. Stop screen sharing. Tech Top. Brave tab. Last programming language. Share audio. Share. Here we go. All right, so if I have to Google something, I'll just Google on the other screen. Here we go.
I especially wanted to go out to the pubs and have some beer and just hang out with everybody. So
So the only thing you miss is that he's really sorry that he couldn't be here today, but that's okay. We forgive him.
Couldn't do it. Sorry. Sometimes life intrudes. But I thought you might be interested in having this keynote anyway. So I've recorded it. I've sent it off. Maybe you'll find time in the bar or something. Get Lakos to buy everybody a big round of drinks, and then you can sit around and watch this thing, huh? So this is the keynote, right? the last programming language. And I'm going to dedicate this to my good friend Kevlin Henney, who, well, you all know what.
Of course. Whoa!
In the very late 1960s.
Jeremiah, were you ready for this production value?
I was not. That hit me like a sack of potatoes.
Dude, I didn't know there was scene changes in this. All right, here we go.
I got myself a copy of this book, Introduction to Programming.
Ah, my favorite book.
Notice that it doesn't say programming what. This was the book that taught you how to program a PDP-8.
What's a PDP-8? Ah.
I happen to have a front panel of a PDP-8. I've kept it for many, many years. Put a frame around it because it was quite a keepsake. The PDP.
What do you think about that, Jeremiah? I think that's kind of cool. I'd have that in my house.
Yeah, I mean, I haven't used my PDP in probably 40 years, so it's nice to see it come up again.
PDP-8 was a wonderful machine. I learned how to program it in the 1960s and early 70s.
Same.
A good PDP-8, let's see, that would be 12-bit word. 4K of Core. Anybody remember Core? And you could turn the computer off and it would remember. Oh yeah, our computers today do that too. It had a 700 and...
Kind of nuts to think about a computer that doesn't save anything when you turn it off. Honestly though, I don't ever turn my computer off today anyway. So I don't know. It's kind of lost on me.
It's a good point. We kind of went full circle with that.
50 kilohertz cycle time. An instruction would execute in about 1.5 microseconds. That was really fast. I mean, we could get lots of stuff done in that 750 kilohertz. 4K instructions. We wrote whole time-sharing systems. You could compile Fortran. They had a Fortran compiler that would run in 4K words. Yeah? Amazing.
All right, what does all this mean? What's he talking about, Jeremiah? He's talking about compilers. He's talking about Fortran. He's talking about cycle speed. Does any of this ring a bell to you?
So I've heard of Fortran, right? And that's ancient programming language. And, you know, nothing back then was like how like Python is now, where it's interpreted and it kind of runs as it goes. But to compile something is where you pretty much squash it all down and make sure it all works together before anything actually executes, which is how they had to do it all the time. It's kind of like C, C++, Java. Those are all compiled languages now.
I see. So you write all your code, and then after you've written all your code, you hit the compile button, and then it turns it into the ones and zeros and makes sure that it works. Is that kind of what's going on?
More or less, I'd say that's pretty accurate.
What's Fortran used for? What's Fortran used for? Okay, Formula Translating System, General Purpose Imperative Programming Language, used for numeric and scientific computing. Developed by IBM. Kind of cool. All right. So now already learning some. Here we go.
Amazing machine.
Amazing
it had, oh gosh, 32K words of disk. If you bought the disk. Usually you didn't. Disks were expensive, but if you needed a disk, well, you could get one, and that would be 32K. It was an infinite amount. It was an incredible amount of disk space. We didn't know what to do with it all. Oh man, we had thing was the size of a refrigerator. It had many dozens of cubic feet. It probably took a kilowatt or more of power, and if you wanted to buy one, it would have cost you in today's dollars about $120,000. Amazing. I have a laptop that I use.
I'm curious where he's going with
thing,
this.
and carry it around in a backpack. It has a processor in it with 2.8 gigahertz cycle time. Actually, 2 cores. So what is that? 5.6 something gigahertz, effectively. That's 8,000 times faster. My little laptop can execute 8,000 times more instructions than that PDP-8 could. That PDP-8 could execute 1 instruction, and my machine now will do 8,000 of them. I have 8 gigabytes of RAM in my machine. That's 2 million times more memory in my little laptop. I have no disk in my laptop. I've got a little over 500 gigabytes of solid state memory. By the way, do not get a disk again ever. Right? No laptop you get should have a disk. The difference is astounding. The age of rotating memories is over.
So by disk, I'm assuming he doesn't mean like an actual disk.
So like thinking of CDs, but also as we just saw in the chat now, hard drives, which are also essentially disks that are in that, you know, rectangular container that is literal spinning memory.
Kind of crazy to look at it when it starts working because, you know, it's not obvious what it's doing when you're looking at it. But okay, that sort of makes sense. So a CD disk and the traditional disk, not the SSDs, but like the more traditional disk, that's like literally a disk inside that's spinning around. I guess it's what, like magnetized or something? Is that?
Yeah, that's exactly right. Yep, HDD were hard disk drives, or what normally people call them hard drives.
Hard disk drive, nice. Okay, that makes a lot of sense. And in solid state, I guess it doesn't use a disk. Is that
Correct.
The difference?
That is correct.
Because it's solid. Okay, what does that look like? Solid state disk. I wish I could show you, but it seems like if you look up a solid state disk, it looks, yeah, there's no disk that I can see. Pretty exciting stuff. And disk in a box, hard drive. Yeah, I agree. Makes cool. That's what Jeremiah was saying. Okay, I don't know. I kind of like this guy though. I'm curious where he's going to take all this. I don't know what this has to do with the last programming language. And we're not going to sit here and watch the whole thing. We are going to skip around some, but I kind of want to see where he's going with all this. Definitely kind of like, you know, I'll say it, kind of a little bit of a ranty vibe, but I'm here for it. I'm interested. Jeremiah, how do you feel about this guy?
I think it's fascinating, to say the least, when you actually get to see what those old, giant, expensive computers were capable of compared to our everyday gadgets, right? And how fast technology has been evolving. And I mean, there's no reason to indicate it would slow down anytime soon. So I mean, in another 40 years, we're going to be looking back at our MacBooks and laughing about how slow and small they were, right? I mean, I think it's going to be super cool to see what comes next.
It's just so crazy because for me, like, you know what I do a lot? I look at like old classic cars, like an old Buick, like from the 80s. And like today, that looks like such an old and like kind of, you know, like junky car. But back then, man, if you had that car in the 80s, man, you were cruising in style. And I just can't, like, the same thing with computers. Like all that stuff in the background would have been the cutting edge high technology not too long ago. And probably in another 40 or 50 years, the MacBook that he has there and the computers in the background might be indistinguishable. Like it might just all look like old tech to people in the future. Like, really? You still use physical computers? We moved everything to the cloud, like in 2030. Where have you been? Kind of crazy. Yeah, what kind of computer could we buy today for 150K? That's a really interesting question, actually. Maybe one of those quantum ones like we were talking about last week. That would have been cool. All right, let's see what Uncle Bob's got.
My little laptop takes 85 watts at most. It is far less than a cubic foot, and it cost me, well, it was an expensive machine, but it was less than $5,000. Oh. Now, if you add up all those differences, you know, 8,000 times faster, 2 million times more RAM, 16 million times more offline storage, it takes 1% of the power, 1% of the volume, 4% of the price, and you multiply all those together and you get this number, 6.4 times 10 to the 22nd. That laptop that I carry around in my backpack is 22 orders of magnitude.
That's crazy.
More powerful than my PDP-8 was. And what have we done with that power? I mean, to put this in some kind of perspective, 22 orders of magnitude, that's the number of angstrom units to Alpha Centauri.
Angstrom
what
units.
Are we doing with that?
It's an angstrom unit.
20 orders of magnitude in the increase in our hardware. And what have we done with it? We programmers. How is programming different than it used to be back then? Wait,
did he say 20? That's the number of angstrom units in Alpha Centauri? Is that what he said?
I believe so.
An angstrom is a metric unit of length equal to 10 to the negative 10 m. That is 1/10,000,000,000th of a meter, or 0.1 nanometer, or 100 picometers. So an angstrom is really small. So does that give you some more context, Jeremiah?
I'm not sure what the Alpha Centauri was, or whatever that term was.
It's like a star.
Oh, is that a constellation?
Yeah, yeah. Let me make sure I'm telling you. Alpha Centauri. Yeah, it is a. It's the closest star system and closest planetary system to Earth's solar system at 4.37 light years. Oh, nice. Pretty close.
So if he's saying we can get there in those angstrom units based on the difference in, I guess, computing power, if we were to make that proportion, I would say that's pretty significant.
Pretty nuts. I don't know. Let's kind of crazy way to put it. I wonder, did he look that knowledge up, or did he just have that in his head ready to go? Very impressive, Uncle Bob.
He's got a calculator
Still right.
under the camera.
Oh yeah, it's about the number of angstrom units in Alpha Centauri. That's what that number means. Okay.
Sequence statements, selection statements, and iteration statements. Assignment, if, and while.
I know those.
We were writing them back then. They had a slightly different form, but that was still sequence, selection, and iteration. And we're doing that today. And we might think, oh, heavens no, we've got objects, we've got modules, we've got all this stuff. Yeah, it's still the same stuff. We are still writing assignment statements, if statements, while loops. Our technology has not grown by 22 orders of magnitude. We've been riding one heck of a ride on that hardware, but not us. Our technology has stayed almost the same. Oh, we've got great tools. But the material we manipulate with our hands, the code, is virtually the same.
2011. Can't even tell. He's so modern. Oh, another scene change.
Have we seen it all?
Let's go.
Have we seen all the languages there are? I mean,
Jeremiah, have we seen all the languages there are?
I know I haven't.
I'm going to go with yes. He's going to say yes. That's my guess. We've seen them all, Jeremiah.
Let's go through a list of the languages, shall we?
Let's go through
I just
a list.
wrote down a list of languages that in my career I have had some contact with. Fortran, COBOL, Snowball, wonderful string-oriented language, Algol, Simula, Smalltalk, C, C++, Java, C#, assemblers, lots of different assemblers, too many to count, probably dozens. Risk-based assemblers, sys-based assemblers, little assemblers, lots of them. Pascal, Delphi, Forth, wonderful language, Forth. By the way, PostScript is Forth, just so that you know. Go, B, BCPL, PL1, PLM, APL, Lisp, Scheme, Scala, F#, Erlang, Haskell, ML, Self, CSOL, JavaScript, Ruby, Groovy, Python, Basic, OCaml, Occam, Prolog. Need I go on? The list of...
All right, how many of those have you heard of?
Towards the end, they were getting more familiar for sure.
I counted, let's see here, like 13, I think, that I got.
That's about right.
I think most of them I didn't know, and the closed captioning system also has no idea. I don't think OCaml is is it? Is OCaml a programming language? Is the closed captioning system better at computers than me? Impossible. I don't know. Probably not. No, definitely not a programming language. Okay. Yeah. I don't know. I don't know a lot of those. I didn't even, you could have told me that half of those are made up and I wouldn't be able to tell you. Yeah. Pretty interesting stuff. Considering that we are considered, globally as being in the top, quartile or whatever of computer science knowledge people, because we're in school for it right now. And it just goes to show you how deep all of this is, because I wouldn't even know. I didn't know how many options you had with programming languages. Python, JavaScript, and then with those two things, you can just kind of go deeper and deeper into Flask and React, and you can just kind of build whatever you want, as far as I know. And then you get into different services and platforms and stuff. But what do you use B# for? I don't know. I don't know. OCAML.
Oh, camel. It's like you're saying, oh, camel.
Okay.
Camel.
I'm gonna look it
Yeah,
up
I've
right
heard of
now.
oh, camel. I haven't heard of oh, camel.
I've seen it written. Yeah, I've seen the words written. Okay, cool. Industrial strength programming language supporting functional, imperative, and object-oriented styles. OCAML. OCAML. Yeah. Thanks, wisest of fools. All right, let's keep going.
Of languages could be endless. I'm sure that I did not mention your favorite.
He did. It's Python. Also, I love his background.
So, given all of these languages, we have to ask ourselves a question. Have we seen them all? I don't mean not all of them. I mean, clearly, there are going to be new languages out there, and we can't see them all. But have we seen all the types? Are there going to be new languages that are in any way surprising, the way Forth was surprising, or the way Prolog was surprising, or the way Smalltalk was surprising? Are there going to be anything new languages like that? Any new big surprises? I think that's a valid question to ask.
Yes.
I'm not at all convinced that there are any more surprising languages out there. We may have seen every type of language there is. After all, it's been over 50 years we've had time to explore this space. So maybe we've seen them all. We can think about all these languages in terms of their syntax. COBOL, for example. Well, it's kind of in a class by itself, isn't it? Fortran, Algol, C, C++, all similar in the way their syntax is organized. Smalltalk had a very unique syntax. Forth, what a syntax that was. Perl, Lisp. These languages can be broken into syntax classes. The let's call it the Algol class. Algol, Pascal, Delphi. They all had this thing called block structure. This was a syntax and semantic component, which allowed you to declare one function inside of another, and so forth. It was actually the progenitor of object-oriented programming.
He's throwing around a lot of terms here, and probably for most people, this might be going over their head. So I want to try and dissect some of that. So he's saying for the first time we had like block structure, which is kind of, I don't know if I'm right. Tell me if you think this sounds right. That has something to do with like our scoping, right? Like I can make a function inside of another function, and then that inner function only runs inside of that function when it's called. And that would have been new back then, is what he's saying. Does that sound right?
Yeah, the word scoping is what actually came to mind for me immediately watching him explain this. And so I'm guessing before that, if everything you declared was global, that could get pretty messy pretty quickly, and then you'd run out of, names to use for your program. I guess, so it's, if this was the first time that was introduced, I'd say that was probably pretty huge at the time.
Imagine if I can't use like I for all of my for loops. I wouldn't even know what to do.
Exactly.
There's only so many letters. Yeah, that's insane. Especially that being a new thing. Kind of crazy to be like walking in late to the party and like seeing all the snacks and all the different festivities that are going on. And we think that this is all just like already been there, but this has been people at the party for a minute who have just been like, all right, let's start making new stuff in here and playing with that. And then we walk into this wonderland. It's kind of crazy. Super crazy. Progenitor of object-oriented programming. Like so much of programming is object-oriented these days. Imagine no object-oriented programming. Kind of crazy. All right, let's keep going.
Most of these languages use a kind of infix and prefix notation. Function calls are prefix. Most operations are infix notation. Smalltalk was a prefix-infix notation as well, although there were no direct operators as such. You had to mix the functions and arguments with keywords in an interesting way. You might call it a keyword language. Lisp is a pure prefix language. Function name first, argument second, surrounded by parentheses, about as simple as you can get.
That's what I'm used to, the simple one.
Same.
I don't even know what the other one is. I didn't get that, but that one makes sense to me. Cool. We're on the same page, right? Scoop.
I think so. I would say that the prefix stuff that he was talking about previously is probably, I guess, close to what we see with Java and like C++, where like your typing of your variables and functions and everything is very strict and verbose. Yeah. Whereas in these other languages, your order in which you place them kind of tells your interpreter or compiler what it's supposed to be. That's what I would make of it, but I, again, definitely not an expert yet.
No, that makes a lot of sense to me hearing you say that. And then I think, all right, and then there's a bunch of a show's only an hour, but I want to know what the last programming language is, and I know that he talks about it like at the end. So let me see if I can like find the spot, because I'm curious where he's going with all this. And yeah, we're only 10 minutes in, and we've already gone 30 minutes. All right, let's see here. Let's just jump ahead to like right.
He's got a hat on in that one.
Yeah, I want to see the yes. Let's start with the hat. Yeah, that's a good spot. Or do we want to do lab coat? No, we'll start with the hat. Let's just see what happens. Right there.
Language. What would that language look like? What would its character?
Oh my God, that was perfect, Scoop. That was perfect. Okay, hold on. That's exactly where we want to be. Let me restart it. 3802. Okay, ready? 3756. Bam, here we go.
Where we actually pick a language, but I think we are capable of doing it.
So I remember watching this. So essentially right now, he's going to say we should pick, let me get to the lab code actually. We'll do the lab code. No, I remember this part now. Okay, we definitely have to see this guy in front of whatever this thing is. Him in the sky.
I'm a conservative. I believe in the market. I'm a Republican in the United States. But
all right, Uncle Bob.
Having these big corporations own our languages is awful. It's terrible.
All right.
They use the languages as levers to twist things and contort things. We, the programmers, have lost control of our very mode of expression. That's not acceptable and has to be stopped. It has to be done away with. Now, it's not hard to do away with this. We're programmers. We have the power to completely eliminate it. We could write our own language if we wanted to. Many of us have. Many of us are.
Yeah.
We could write a language and just do away with the corporate ownership of languages. And we must. At some point, this corporate ownership of language has to end. Because we don't want to be the pawns of Oracle or Microsoft or IBM. We want to be able to express ourselves in a language of our choosing, not some corporation's choosing.
Jeremiah, down with the power. Uncle Bob's got me fired up now. No more Oracle languages. We should be able to make our own language. What do you think about all that, Jeremiah?
I think it's really interesting for him to bring that up because I just learned about Microsoft's new initiative where they're, kind of open sourcing a way for them to like help debug repos that are submitted and for them to like have a language that automatically like fixes code for you. But then at the end of the day, like, how do we know they're not using this kind of code to straight up rip off people's ideas and code bases, right?
That's true. That's true. And, hearing him say that, it was kind of, it is a hot take. I see in the chat, Uncle Bob hot takes. Yeah, no, this is a very hot take. But one of the great things about a good hot take is that it does force you to kind of think about it in a different type of way, because I had never even considered that these languages are created by different companies and different corporations, and that we kind of are relying on them as programmers to be able to do what we do, which is make stuff. I've never thought of that before, and I've never even thought about if that is something I should be concerned with or if that's a problem. Uncle Bob seems to be pretty concerned with it. And I think regardless of whether or not I agree with him on that, I am kind of curious what his solution to all this would be. Because I think probably more open and less centralized. That's kind of the direction we would want to go with our programming language. Does that make sense to you?
Yeah. I think it kind of loops back to the beginning where he was talking about how even though the hardware and everything is so advanced, the way we use our programming languages hasn't grown that much. And I think that's because we're almost bottlenecked by everyone relying on these companies to release these new functionalities of programming, right? As opposed to us exploring on our own, we're kind of bottlenecked by the corporation. But that's not their fault. That's our fault for relying so heavily upon them, right? Does that make sense?
That makes a lot of sense. In fact, I like what you said, and that's my opinion too. What you just said. That's really good. Hearing you put it like that. Yeah, that makes sense. Well, I'm curious to see what his solution is going to be. Let's see.
So what's the likelihood that we could actually pick a language? You know, a bunch of programmers, getting them all together to choose a language is sort of like herding cats. Well,
impossible, yeah.
What encourages me about this is that we've done it before. We have chosen languages before. Not quite as globally as I'm talking about here, but consider the language C. C dominates every language we use nowadays. Think of Java and C# and C++ and even Ruby, dominated by the C syntax. We chose a notation with C.
Small thing. I love the way he says Ruby. He really emphasizes that. Ruby. You know, I love that. Okay.
The C notation, one way or another, has become the de facto standard. Even in something like Ruby, we see C notation permeating all through it. So we are not incapable of making these kinds of unifying decisions. It may be time for us to do a little bit more than choosing bang equals for not equal. It might be time for us to instead of double equals or something like that, it might be time for us to do something more, some grander choice where we actually pick a language, but I think we are capable of doing it. So let's say that we did pick a language. What would that language look like? What would its characteristics be?
What's he got there?
Maybe we can get some insight on this by looking at some languages we know. For example, would this language be C?
Yeah, I thought it was like a little toy like lightsaber without it being extended.
Yeah.
And I love that hat too. What kind of style hat is that? It's like a Australian Mountie hat or something you've seen in the, you know, with the brim. This part's up, this part's. Oh, dude, I gotta get that hat. What's that say? Royal what museum? Well, let's keep watching, I guess. Going to the chat, I don't know if I agree that programming language have stopped changing. Rust and Dart are good examples of languages that have pretty sizable paradigm shifts. Not exactly the same thing, but the features that modern C++ is introducing exist nowhere else. I think he does talk about Rust, but yeah, no, that I'm sure a lot have changed since 2011. Maybe they listened to him, and we're just now again late to the party. But let's keep going.
Well, there's some problems with C. It's not garbage collected. Do we really want to go down that path again?
Garbage collected.
You can't do reasonable polymorphism in C. I mean, you can hack the pointers to functions, but God help you if you do. It's compiled down to a real machine. There is no virtual language for C. It just seems out of focus with where we are now. We don't want to be tied to hardware any longer. The language does not allow you to modify it while it's running, and you cannot, fiddle around inside the running C program while it's running. It's not homo-iconic. C++.
Homo-iconic. Jeremiah, you can't run it while it's you have to compile it first before you can't mess with a running program. These are all very interesting differences between languages that I don't think I ever fully appreciated until I hear Uncle Bob sit here start to compare them all.
Yeah, I mean, I think we've been spoiled with learning Python first, I guess, for at least some of us that took that route, because now when I'm trying to backtrack and go learn how to type in languages like C, I feel like there's so many rules. It's ridiculous. It's like going from recess to a prison. It's it's tough.
It really is.
It's nice to know what it was like so we can really appreciate the privileges we have today when it comes to coding.
Yeah, and the thing with the pointers and all, like I never even, what's polymorphism and garbage collector. So garbage collector, we need to take our stuff that we don't want to use anymore in our memory, and we need to get rid of it. And I guess you can't do that in C.
Well, C doesn't do it for you, whereas Python does. So in Python, when we create an array and it's used and we're done with it, and like let's say we empty it out, Python at some point will just get rid of that for you. In C, I'm guessing that memory stays allocated for that empty array, even if we never touch it again. So we have to free up that memory manually.
That's crazy. And no polymorphism. So that would mean you'd have to write a lot more code too, because you can't have an instance that operates as like different things. Okay, very interesting. Yeah, let's not use C. Let's see what else we got.
So what about that? That's all the same problems that C has, and boy, is it's syntax heavy. Learning all that syntax is just horrible. And now, I mean, the standards committee has just gone completely ape. Right? They're just adding syntax, lots of little fiddly stuff in there. I think I'd rather not learn all.
Finally, someone's sticking up for us with the, yeah, what are you doing all this fiddly syntax stuff for? I love this.
All that stuff. Java.
All right, Java, yeah.
It's not a functional language.
Okay.
It doesn't have the solution to Moore's law that we're all hoping for. So Java, it's a pretty good language other than that, but it's a little syntax heavy. Maybe we should do something better than that. C#, same thing. Same thing. C# and Java, I mean, no difference. They're the same language. So...
Uncle Bob hot takes.
What
love it.
should the language look like? What should its attributes be? So, what semantic class should this language belong to? What paradigm should it support? Should it support just one or all of them? Should it be a functional language? Should it be a structured language? Should it be an OO language? Or many of us would probably prefer that it was a hybrid language.
Yes, me too.
But let me make this statement about hybrid languages.
Hot take incoming.
When a language belongs to all semantic classes, it doesn't belong to any of them. Because remember that paradigms, semantic classes, are about restrictions. If your programming language allows you to do assignments, then it's not functional, even though it might allow functional programming. Scala, for example, is not a functional language. You can do functional programming in it, but the language itself does not force the paradigm. C is not a structured language. You can do structured programming in it, but it's got to go to. So you can do non-structured programming in it. C++ is not an object-oriented program because it has pointers to functions. And if you can deal with pointers to functions in the raw, you're not an object-oriented language. So the hybrid languages keep all the power that the paradigms have been trying to constrain. Hybrid languages don't belong to any functional class. They aren't paradigm-based languages. They are anything languages. They're unconstrained languages. What do we want our language to be? Do we want it constrained? Or do we want it to have all the power? The power!
Jeremiah, what do you think? Do we want our language to have all the power?
That's a good question. So while he was talking about this, I was more trying to analyze what he was saying exactly as far as what makes something a functional language as compared to an object-oriented language. Since I don't think I know enough about the topic to really be able to follow that closely, but it's fascinating. And it sounded like almost he was bagging on anything languages until we got to this point. I'm like, you know what? I think this is where our last language would come in, where it is a hybrid, not constrained, something that can work in all facets.
Yeah, slowly but surely we are starting to piece together this puzzle. I think he's like laying out a case like a lawyer. Like he first demonstrated like an overview of the history, and then he gave us the problem with the corporate control, and we also have these languages that all have their own problems. But if we had a hybrid language, that like didn't have corporate control, maybe that's the direction we want to go in. I think that's where he's going with all this. And I kind of missed a lot of the nuance there with the go-tos and the different paradigms in different languages. But I don't know. I don't know if that is even necessary to know for his overarching point, because I'm familiar enough with what's going on, but you know, I don't have Uncle Bob years of experience with all these different languages, but I can still follow along with his overarching point. Is that where you're pretty much at too?
Pretty much. I definitely have some good Google feel for later.
Yeah. I kind of want to watch this a few times and like really slowly go through and like look at, okay, C# go-tos. Try and really figure that out. All right. Let's see. That's my Saturday night. All right, let's see. Here we go.
Spock here. Another thing we want out of our languages is simplicity. And by that I mean simplicity of syntax. Think of a language like Forth. There's almost no syntax. Think of a language like Smalltalk. Almost no syntax.
Never heard of it.
Or Lisp. Again, almost no syntax. Just lots and lots of parentheses.
Heard of Lisp.
Now think of a language like C++. Now, I love C++. I do, a wonderful language, but there's syntax there. Think of Java, syntax. Think of Scala, syntax. I think we've had enough of the syntax-heavy languages. I think we've had enough of language lawyers. It would be awfully nice if our language had a very simple syntax so that we could focus on semantic issues instead of syntax issues.
I'm with him there, Jeremiah. You agree?
100%.
No more of this parentheses nonsense and having to bool this and everything. I don't know. I'm with him there.
Still, another attribute of a programming language that I think we want is polymorphism.
Yes.
We want dependency inversion. We want to be able to control.
Yeah, so by polymorphism, he's just talking pretty much about object-oriented programming, right?
100%, yes.
Cool. Just making sure. That's sometimes these people, they throw in these fancy words for stuff that I know of, but I just know it by a different word. That's always what trips me up. Okay. And I know polymorphism, the word too. And I know we went over that, but it's just, it's been a little while.
Control the way our modules depend upon each other. We want to be able to set up our modules so that the source code dependencies oppose the transfer of control, the flow of control. And that's what polymorphism gives us. So any language we choose should have polymorphic ability. But that's not what an OO language is. An OO language gives us a constraint. It says we can't use pointer to functions. We must instead do our dependency management solely through polymorphism. I think this is important. I think we want our languages to be polymorphic and constrained. I think we want the discipline imposed upon indirect transfer of control. And we want our language to run in a virtual machine. This is another lesson we've learned over the years. We don't want to be bound to the hardware. We don't.
Hold on, that's the most goated scene transition I've ever seen. Dude, look at this guy. He's flexing on this. Hold on. Let me see that scene transition one more time.
And we want our language to run in a virtual machine. This is another lesson we've learned over the years. We don't want to be bound to the hardware. We don't want to know about the hardware. We don't want to have to always run our machine on an Intel platform when there's all these other platforms out there.
Honestly, Jeremiah, I think I'm looking at a window into the future for myself. Like, that is really funny. That's something I would do. Like, dude, where do you find that hat? He doesn't even have it buttoned up. Dude, that's hilarious. But also to the point he's making, yeah. No, I think it's, I agree with him. I've always thought it was rather strange that I could only code like Swift on an Apple machine. it feels like for computers, I should be able to do computer stuff on any computer. You know what I mean?
100%. I think being platform agnostic is probably the best quality of life thing that we could get right now.
Yeah. Yeah. Like if it's possible, if it's even possible to make Swift work on a Windows machine, I feel like it would be a good thing to do that. Like if we encountered another civilization out in space and all of their programming languages were platform agnostic, they would probably look at us like, what are you guys doing? Like, why are you doing it that way? That's weird. And I would be like, yeah, I agree. It is pretty weird that we do that.
It reminds me of like how the new Apple processors kind of threw a bunch of work onto Google and their Chrome browser, right? Because they had to tweak a whole bunch of stuff there just to make it, I guess, work how it was supposed to on the new M3 chip. But
these people, where do they get away with that? I guess they can do that, but I don't know. I agree with Uncle Bob. I agree.
Yeah, well, anyway, we want to be able to run on any platform.
It compiles down to LLVM space IR. Does that mean anything to you, Jeremiah? What does that mean?
I almost wanted to read that as Roman numerals. That's how much I know about LLVMIR.
LLVMIR. Low-level intermediate representation platform independent assembly language with an infinite number of function local registers. Huh. Platform independent assembly language. Huh. So it's using Go? Is that true? I'd be curious to learn a little bit more about that. Very interesting.
We got to get the wisest of fools on here.
Yeah, I don't know who that is. Who are you, the wisest of fools? Yeah, that's really interesting. Guest feature from the chat. I told you
that
Twitch
we
chat
want to.
knows everything.
And so we want virtual machine. Whatever language we choose should be a virtual machine language.
Yes, VM language. Here we go.
Whatever this language is that we choose, it should also have access to all of our frameworks. It should, for example, work with the JVM. It should be able to work with Java. Java should be able to call it, and it should be able to call Java. C# should be able to call it, and it should be able to call C#. The major virtual frameworks that are out there should be.
Happy to have you here, Alex. Make School 2016, showing love from the alumni. Thank you. I will. Wisest of Fools is a window into my future as well. I'll probably be here in 4 years on the Twitch. Let's go.
Be able to work with this language without any problems. We obviously don't want to divorce ourselves from the vast libraries of functions that have been created.
Yes,
we don't want
important.
to throw away these massive enterprise frameworks. So whatever this language is, it will have to be able to work with those frameworks well. And there are a few contenders. I mean, there are versions of Ruby that work on both of these platforms. There's versions of Python that work on both of these platforms. There's Groovy that works on the Java side. I don't think it'll ever go on the .NET side. And there's Clojure that works on both sides as well. So we want a language that fits in all of the virtual frameworks that are out there so that we can maintain access to our libraries. I think we want this language we choose to be structured. And by that I mean it should not have a go-to. It should impose discipline on direct transfer of control. I think we want it to follow the structured paradigm, which means it can't be C or C++. They have go-tos in them. Right? We want this discipline imposed upon direct transfer of control. So,
what am I looking at here in the background? So it looks like some sort of diagram for like a flow, like a flow of how a program works. Is that what it looks like to you?
That's what it looks like. So like, yeah, it looks like so they order an item and the first check is it a new customer? If it's false, then it follows that line of logic, right? To
right.
The left.
Yeah.
Huh.
That's a really, I've never seen this type of diagram before, but that's really interesting.
I like it.
Until customer name equals customer data number. Huh. Maybe he'll go over it a bit. Let's see.
Java, there's no go-to in Java, although they do have those dumb numbered breaks. Dumb. C#, I think there's a go-to in C#, but nobody uses it. Closure? No go-to. Ruby? No go-to, as far as I know. We can do languages without a go-to, and I think this language that we choose, whatever it is, should not have a go-to.
All right, what's a go-to? I'm going to ask. What exactly is a go-to?
A go-to is a statement found in many computer programming languages. It performs a one-way transfer of control to another line of code. I don't know exactly what that means, but I Googled it about 3 minutes ago because I was curious as well.
Yeah, that's also what I Googled. Statement found, all right, performs one-way transfer of control to another line of code. In contrast, a function call normally returns control. So with a go-to, I'm saying go to this piece of code and then leave me alone forever, and now you have all the control. Is that kind of what's going on? Whereas if I did a function, it would return back to the original piece of code because I just kind of perform an operation somewhere else and then I come back. Is that kind of what's going on?
From what I'm seeing, it allows you to jump to different spots in the program. And as Make School just said, that there's no guarantee you'll get control back. I'm guessing you have to be really on top of like sending it back to where it needs to go.
Yeah,
I'm seeing a lot of negativity about using go-tos.
Yeah, one of the top questions is, why is go-to bad? Using a go-to to jump out of a deeply nested loop can often be cleaner than using a condition variable and checking on every level. Using go-to in one of the subroutines in the main way is abused. This creates so-called spaghetti code that is unnecessarily difficult to read and maintain. This is the culprit of the spaghetti code, is the go-tos. Okay, now I understand what's going on. They were popular, the wise the fool says, in some early languages, but our industry decided they were a bad idea because they made code really hard to follow. Yes, that's what Google also said. Now we have independent verification, giving the basketball to a teammate who can now choose where it goes next. Oh, yeah, I would never pass the ball to anyone on any basketball team.
Right.
Yeah, I would just shoot
How
the
am I
ball.
supposed to score?
Yeah, to score more, you got to shoot more. All right, let's see if we can finish this video before in 3 minutes. Let's see if we can finish the remaining 9 minutes in 3 minutes. Here we go.
And another thing we've learned is that we want our languages to be garbage collected. We've learned our lesson on this. We don't want to be doing manual memory control anymore. My God, how many times have we been rebooting at midnight because of horrible memory leaks and stuff like that?
Yes.
We've learned our lesson on this. And Apple, are you listening? I mean,
Apple, are you?
Objective-C? Really? Objective-C?
Really, Apple?
How old is this language? 1979, Brad Cox invents this thing, and it almost died. We almost got rid of it. It was in the garbage can when Steve Jobs pulled it out of the garbage can and resurrected it. God help us forever. Anyway, garbage collection. We want our language to be garbage collected. Good. This is excellent. Good. Hello, Twinkles. What did the room animal? Oh, yes, what is the room animal? Oh, yes.
Oh, boy.
Yes. Whatever language we choose, we want it to be fast. C is fast, right? We want a language that really moves. Yes. I know. We want it to move along quickly. We want it to be a snappy language. C is a fast language. Assembly language, fast language. C++ is a fast language. Ruby, not so fast. Python, a little faster. Closure, pretty fast. Quick language. F#, fast. Scala, fast. Basic, slow.
Slow.
We don't want these slow languages. It's going to have to be snappy. The next thing we want is a language that is symbolic. We don't want the language tied to the hardware. We don't want it to be like a machine language or even have any of the trappings of the hardware. We'd like our language to be symbolic, abstract. C is a language that is too close to the hardware. We know that an int, for example, is 32 bits. C++ has the same problem. Even Java has bits of that problem. It's close to the metal. Well, that's tough to say Java's close to the metal, but it has trappings that are close to the metal. Smalltalk is a language that's not at all close to the metal. Clojure is a language that's not at all close to the metal. Ruby, not even close, right? So we'd like our languages to be abstract so that we're not coupled to the notion of hardware. And then finally, we want our languages to be textual. We've tried the symbolic language before. We've tried the graphic language, We've tried the graphic languages before, and although they're interesting, they just don't really do it for us. And something about the programming domain, like the mathematical domain, is textual in nature. There's something serial about it. There's something one-dimensional about it. The reasoning inside of a software module is one-dimensional. It proceeds in a direction in time. So it's not at all clear that a graphic language is what we want. We probably want a textual language. Yeah, that's right. That's right. Okay, yeah.
Oh. Going to the chat. They did listen. Oh, good. Swift uses automatic reference counting as an alternative to GC, which I guess is the Objective-C thing. Cool. Galactic Bacon says this guy's like a Bond villain, which I didn't see, but then now that you say it, okay, kinda. Like, I could see this guy being the Bond villain that, like, in the beginning of the movie, like, oh, he's a cool guy, and then at the very end, he's like, haha, I have all the power now. And you're like, what? That guy's a bad guy all along? But then, you know, in the second movie, he was actually the good guy. I don't know. Oh, garbage collection. Okay, cool. And holding his dog menacingly. Yeah, cute dog. 10 out of 10 for the dog. Scoopy?
I'd give it a 9.5, but still a good dog.
Yes, harsh judge, of course, but that's why he's the expert. Nothing impresses him so easily. Did you catch that with the symbolic and the textual language?
Not at all.
Yeah. Okay. I didn't really either. So maybe he'll. Okay. Let's see.
The dog is a little distracting.
That's all I can pay attention to.
Another language attribute that I think we want is homoiconicity. I know, that's tough to say. We want our languages to be homo.
Another 3 minutes left, so I just want to hear what his big solution is, and then I'll be happy. But I have to hear the solution. We're so close. I know we're over time, but we're so close.
My next video for our solution on the last programming language. I'm waiting for it. It's going to be baiting.
Oh, I'll be so mad.
Iconic. In other words, we want the languages to be able to manipulate themselves. The running program ought to be able to construct more running program or alter more running program, just like a machine language program can do, and just like most Lisps can do. We want this ability to be able to manipulate the code while it's running. Ruby has some of this capability. We call it monkey patching or meta programming. Even Java has a small bit. You can manipulate bytecodes, but God, who wants to? So whatever language it is that we choose probably should be homoiconic. By the way, Ruby is not homoiconic. Neither is Java. Oh yeah, you can reach in and fiddle with the bytecodes or goof around with the Ruby inheritance and class structures, but that's not quite the same as saying that the code is the data. The data is the code. That's a very powerful statement, and I think we want our languages to have that capability.
I'm with them.
So what language is it that meets all these criteria?
This has got to be the final scene. This is such a grand finale.
Yeah. Fireworks and everything.
What language would I choose if I had to choose today? Probably Clojure. It's the only one that meets all the criteria I've outlined. I think it's a good language. I think it's an interesting language. Will it be the language? Oh, probably not. Probably not. We will probably continue to twist and turn in the wind for a while. But I imagine that we will choose a language soon. And by soon, I mean some number of decades where that number is probably larger than one. I presume we will choose a language. I presume that that language will have all of the features I've just outlined. It might even be something that looks like a Lisp, maybe like a Clojure. So, take a look at Clojure. See if you think it could be the last programming language. Well, so thanks everybody. I appreciate you watching, and sorry I couldn't be there. I really wanted to be there and have a few pints and listen to some great talks, but I hope you enjoyed this one. I wish I could have delivered it live. Guys, have a lot of fun, and maybe I'll be able to get there next year. I sure hope so. Really? Talk to you all later.
All right.
If that last scene wasn't him doing the classic old person like taking a selfie angle, I don't know if I would give it 5 out of 5, but no, I can.
You know, he's just such a natural. He's just one of these guys. He just naturally knows what's good. Like I bet he's someone that I bet that if there was a grandkid or like some professional that was trying to advise Uncle Bob, like, here's how you should shoot your video, they would have got him completely wrong. Whatever he thinks, I think I want to go with, because his natural instinct there with this video is just perfect. That was perfect. That was a perfect outro. The thing with the hats, perfect. This guy's great. I'm a big Uncle Bob fan now. What do you think?
Oh, 100%. The scene transitions and the
yeah.
I guess the sudden transitions were what caught me, and it wasn't too distracting. It was just funny enough to keep me engaged. Like, let's say I didn't know anything about programming. This was all going way over my head. At least I could enjoy that portion, right?
That's why I picked this. That's why I picked this video, is because I kept seeing those scene transitions. I was like, okay, probably a really dry subject, even for people who like computer science. But those scene transitions, that's you come for the code, you stay for the scene transitions, I think.
Right.
Yeah, I didn't catch what the mug was. And yeah, so apparently, Jeremiah, Clojure, that's the language. Who would have thought?
I've got about 12 other books I got to get through first. But I mean, it's nice to have seen this, because now I'm introduced to a couple other ones too, right? Because I mean, you said what, Lisp about 47 times? I should probably figure out what that is too. If it was a big deal 9 years ago, I'm guessing it hasn't phased out completely quite yet.
So I guess that's why we kept having this strange logo in the background. I didn't know what the Clojure logo was. I guess that would have been a clue. Okay, so this is the Clojure logo. You can still see my screen, right?
I can see the last programming language.
Because I'm only sharing the tab. Okay. Well, anyway, if you Google Clojure, the logo for Clojure is the same one that was in the background that was like a panning or zooming into it. And I'm looking at some of the code right now. Hold on, I'll share it, and then we'll get out of here. I know we're over time. Let me share some of this code, and I'm gonna go back here, and I have to do this, and then I have to stop screen sharing, and then I'm gonna reshare the screen, application window, this whole thing. Yeah, here we go. Right here, and then now you can see it, right?
Yep.
Yeah, so this is the logo. So now that makes a lot of sense. And okay, let's see here. Easy on the eyes. Can I full screen this picture? Open image in the tab. Okay, can I zoom in? Yeah, so you can see this, right?
Yep.
This is the best programming language, apparently. Not sure what's going on.
He did give it a big maybe, but I think since this was his choice at the end, he seemed like an educated enough dude to at least want to dive into this at least a little bit.
All right, here's something with the DOM. I know that. Here's something with components. Here's an object over here, because we got a this dot. Initial states, function, keys, name, age as params. This is kind of interesting looking at it. So we can put our parameters in like that. Query. What's the query for? UI person, comp factory. Do you have to make a... I've heard of this thing with factories in Java before. Kind of intimidating looking at this, not gonna lie. But I'm sure if I sat there and really looked at it, it'd be cool. What's in here? What's in this one? Open image in new tab. Any big Clojure people in the chat? Is this what normal Clojure looks like? Holy cow! You seeing this, Jeremiah?
Those just look like imports at the top.
Yeah, those are imports. Okay, so we can do server stuff with it too, because we have this router.
Right.
Huh. Well, there you go. Clojure. If you are interested in Clojure, you can go ahead and check out Clojure at your leisure. And if you find something out that is really super cool, you can come and tell us about. You can come tell us about it in the Discord, and I can give you a link to the Discord. How do I see the Discord? Well, you just go right there. It's going to pop up on the screen, make.sc/join Discord. You can follow us on Twitch at Make School, which is what you're probably watching right now. If you'd like to watch past streams of both my show and Aaliyah's show, you can watch them here at the make.sc watch archive. If you want to just watch all the best and the latest and greatest in the previous show with Jeremiah, you can of course go make.sc/watch tech topical. And if you would like to come to Make School and hang out with me and Jeremiah, you can go to Make School /apply. And that's kind of cool how we can have all those links pop up there on the bottom. You see that?
That's pretty snazzy.
Yeah, pretty snazzy. Yeah. Well, anyway, that's our time for today. I had a good time. I hope you did too. The Wise the Fool says, I really like learn X and Y for syntax rundowns. Nice, nice, nice. And we have all these links getting thrown into the chat, so go ahead and check it out. And big thanks, of course, to my guest, Jeremiah. Follow him on Twitch at, what's your Twitch handle?
It's Scoopy.
It's Scoopy. It's Scoopy. Go ahead and follow him on Twitch. And thanks for coming out. And this has been Tech Topical, Tech's Best Talking Show. I will see you all next week. Same time, same place. And I will see you all next time. All right. Bye-bye. And